All right, let's talk about a core C-sharp concept that trips up so many people but is absolutely essential, especially in interviews. We're talking about method overloading versus overriding. By the end of this, you're going to get it, for real.
And look, I know what you're probably thinking. Not another animal class example, right? If you see one more dog that barks or a cat that meows, you're going to scream. So don't worry, we are completely ditching those textbook examples. We're going to look at how this stuff works in a real project, something you'd actually build, like a payment system. This is the kind of stuff that shows up on the job, and you guessed it, in technical interviews.
So let's kick things off with a problem every developer faces: flexibility. You've got a piece of logic, a method, and you need it to do basically the same thing, but with slightly different pieces of information. How do you handle that?
Let's get specific. Think about a payment service. You need a way to calculate the final price. Easy, right? Well, what if sometimes you just have the amount? Other times you've got the amount plus tax, and then maybe you have all of that plus a discount. You don't want three different methods like calculate total with tax, and calculate total with tax and discount. That's just messy. So how do you make one clean method that can handle all of these situations?
And the answer, my friend, is method overloading. It's beautiful. Check out this payment service class. We have three methods, all with the exact same name: calculate total. So how does C# not get confused? Well, it looks at the parameters, the method's signature. One version takes just the amount. The next one takes the amount and the tax. The third takes all three: amount, tax, and discount. C# is smart enough to see which one you're trying to call based on the data you give it. It's just really convenient.
Okay, so let's recap overloading. Here are the must-know facts. First, it all happens within the same class. Super important. Second, the methods share the same name, but they must have different parameters. That's the whole trick. And here's the kicker for interviews. The choice of which method to use is made at compile time, before the program even runs. At the end of the day, overloading is all about programmer convenience.
All right, so that's input variation sorted. But what about a different kind of problem? What happens when it's not the inputs that are different, but the actual behavior of the method needs to change? This is where we shift gears from simple convenience to something much more powerful: specialization. Back to our payment system. Think about it, processing a credit card payment is totally different from processing a UPI payment, right? With a credit card, you're hitting validation services, talking to bank APIs, running fraud checks, a whole bunch of steps. UPI is a completely different workflow. The action is the same: process a payment, but how you do it is fundamentally different. So how do we model that?
And this brings us to method overriding, which is at the heart of polymorphism. Take a look at this code. We've got a base class, payment gateway. See that little virtual keyword? That's the key. It's like the base class is saying, hey, here's the default way to process a payment, but if any of my children have a better idea, feel free to step in and do it your own way. And that's exactly what happens. The credit card payment and UPI payment classes accept that invitation. They use the override keyword to say, thanks, but I've got this, and they provide their own unique implementation.
Now this is where the magic happens. Look at this line of code. We declare our variable as the base type payment gateway, but we're actually creating a new credit card payment object. So when we call payment.processPayment, what happens? Does it run the generic code from the parent? Nope. It runs the specific overwritten code from the credit card payment class. C# figures this out at runtime while the program is actually running. It looks at the real object that payment is pointing to and says, that's a credit card payment. I'll use its method. That right there is runtime polymorphism.
Okay, so we've seen both overloading and overriding in a real-world context. To make sure this really sticks, let's put them side by side in a direct comparison. This is the cheat sheet you'll want to screenshot for later. Let's just quickly walk through this. Scope: overloading happens in the same class. Overriding: you need inheritance, a parent, and a child class. Signature: this is a big one. Overloading needs different parameters. Overriding demands the exact same parameters. Inheritance: overloading doesn't care about it. Overriding requires it. Decision time: overloading is figured out at compile time. Overriding is a runtime decision. And finally, the purpose. Overloading is for input convenience, while overriding is for changing the core behavior. See the pattern? They're for totally different jobs.
Okay, imagine you're in an interview. You're nervous. You need to explain the difference fast. What's the one simple idea you can hold on to? Let's boil it all down to the absolute essence.
Overloading is all about input variation. Different inputs, same basic action. That's it. If the parameters are changing, you're looking at overloading.
And the other half of the coin. Overriding is all about behavior variation. Same input, same method name, but a totally different way of doing things. If the how changes, it's overriding. So, you see, this isn't just some abstract theory for an exam. These are tools you'll use constantly to write cleaner, more flexible, and more powerful code. And that really brings me to a final thought for you to take away. The next time you're coding, take a second and look at your own projects. Where could you use overloading to make an API more convenient? Or where could you use overriding to handle specialized cases more elegantly? Think about it, because that's where this knowledge really comes to life.